Good morning, everyone. I hope I am audible. Please write on the chat if I am audible. Okay. So my name is Umang Kejriwal, and on the behalf of Finland Labs, I welcome you all to the live online webinar on embedded system with robotics. So welcome to the Finland Labs. So in today's session, I will be giving you the overview about embedded system with robotics. What is embedded system? What is robotics? What are the different mechanism of robotics? How the robot work? These all things I am going to discuss today, and I will introduce about one platform which is Tinkercad, which is used as a simulator for the embedded system. So these all things I am going to discuss today. So for one thing I would like to tell you about the session today, like you all will get your e-certificates for this session, and you need to fill a attendance form for the certificate. So we will provide the link of the attendance form during the session, maybe 15. Yes. Yeah, so please confirm if you can see the PPT. Regarding the certificate, I will tell you, we'll provide the link which you have to fill, and those who will provide the link, fill the form, they will only get a certificate. I'll provide that link after the session, just 10 to 15 minutes before the session. So for the certificate, I'll tell you later on. First of all, please focus on the session. This is very important. So we are gathered here to know about embedded system. So first of all, what is an embedded system? So if I ask you about embedded system, it is one that has hardware, and hardware is basically the microcontroller or microprocessor, and software embedded inside as its important unit to perform certain tasks. Now, what is the meaning of this? Basically, we can say in short that embedded system is a combination of hardware and software, where the hardware is being controlled by a software. So basically, we have a hardware. Generally, the hardware that we have in the embedded system is microcontroller or microprocessor. And if you are from electronics background, you must be knowing about this microcontroller or microprocessor, because this is a common topic in the engineering in the first year. So you must be knowing basic about this microcontroller and microprocessor. So this is the hardware that we have in the embedded system. So this hardware is being controlled by a software. And if we are controlling this with a software, then this is called an embedded system. Like, as for example, you can take an example of a air conditioner. Like in the market nowadays, we have an automated air conditioner which takes the which switch on and switch off the AC according to the temperature. Let's say if you have set the temperature that as soon as the room temperature goes up to, like, let's say 20 degrees Celsius, switch off the AC. So there is some programming which is going in the background, which is running in the AC, which checks for the temperature. And as soon as the temperature reaches 20 degrees Celsius, the AC automatically turns off. So this is all example of embedded system. You can take example of our laptop. In our laptop, there are so many hardwares which we control with different softwares. Like, as for example, speaker. We have a speaker in our laptop and we play music with some software. So that is also an example of embedded system. Okay, so this is simply an embedded system. Now the software resides inside the chip in flash or ROM memory and execute itself when mandatory condition becomes true. So the software, basically it is inside the chip, or we can say a flash memory, where we store the program. Okay, and those who are not getting the PPT clear, please make the video quality to higher. Maybe your video quality is low. Go to the YouTube settings and make the video quality to higher. You will get the PPT clear. Your video quality may be lower, that is why you are getting the PPT blur. Okay, make it to 1080 resolution or 720 resolution. You'll get the clear PPT. Yeah. Now, industrial machines, automobiles, medical equipment, cameras, household appliances, airplanes, vending machines, toys, as well as more obvious cellular phone. That these are examples of an embedded system. So all these appliances that you see in your nearby surrounding, like it may be some machine, automobile, medical equipment, cameras, your mobile phone, your laptop, airplane, these all are the example of an embedded system. So in short, just understand, embedded system is a combination of hardware and software, where software controls the hardware. That is what embedded system is. Okay. Now let us discuss some example, like refrigerator. We have a refrigerator where the food that we have in the refrigerator, according to the type of food, the temperature of the refrigerator adjusts automatically. So there is a chip embedded inside the refrigerator, and there are so many sensors which fetches the different quantities, and according to that it adjusts the temperature of the refrigerator. So that is also an example of embedded system. Okay. Then car door, like in the cars we have automated door which can be controlled by the driver itself. Driver can make the car door on and off, or lock the door from his place only. So there is a single button. When he press that button, all the doors of the car automatically turn like locked or unlocked. So these are the examples of embedded system. There is a chip in which some program is written, and that program is every time executing. Okay. Yeah. See, please go to the settings, resolution setting, and change the resolution to 720p. Your PPT will be clear. Your resolution is low. That is why you are getting a lower resolution, lower PPT quality. Okay. Check that. It will work. Now coming to the robotics. So I hope through till here the embedded system is clear. In short, it is just a combination of hardware and software, where software controls the hardware. Okay. Now coming to the robotics. Now what is robotics? It is a branch of technology that deals with the design, construction, operation and application of robot as well as computer system for their control, sensory feedback and information processing. So basically robotics is a branch of technology where you deal with the design, construction, operation and application of robot. So whatever thing is required to make a robot, that is called a robotics. That is a part of robotics. Now, what is a robot? Like, can anybody tell me on the chat how can you define a robot? What is a robot basically? How can you define a robot? Anyone? It is a pre-programmed machine. Machine works on its own with the help of program. Okay, correct. Basically, see, in short, in simple word, if I explain, robot is simply a machine which makes our work easier. In simple word, it's a machine which makes our work easier and should have some features. What are some features I will discuss about in the coming slide. So a robot is a machine which makes our work easier, faster, and give us an accurate output, and should have some features. So what are the features? I'll discuss after some time. So basically, any machine which makes our work easier is not a robot. See, if I talk about washing machine basically makes the cloth cleaner, right? It cleans our clothes, but it is making our work easier, but we cannot call it as a robot. Fan, it gives us air, we cannot call it as robot. AC, we cannot call it as robot. These all are the machine which is making our work easier, but we cannot call it as a robot. Robot should have some characteristics, some features, which I'll discuss after some time. So that should be there in the robot or in the machine. Then if these features are there in the machine, then we can call it as a robot. So this field overlaps with electronics, computer science, artificial intelligence, nanotechnology, bioengineering, and branches of science. So basically, in short, we can say that this robotics is a combination of all the branch. It is common to all the branch. It is not like that if I am from civil branch or if I am from mechanical branch, I cannot learn robotics. Anyone can learn robotics if you have an interest. So it is related to every branch, because whatever we do in robotics, it is related to all the branch, whether it is mechanical, electronics, computer science, but the main core branch of robotics is electronics. If you go for the hardware part, the main core branch is electronics and mechanical. Okay. Yeah, so a robot can be defined as a programmable, self-controlled, with presence of artificial intelligence consisting of electronic, electrical, and mechanical units combining all, must possesses mobility. So this is a very important part of this, that it should have the mobility. It should have some kind of movement. If there is no movement, we cannot call it as a robot. There should be some kind of movement with, so that means we should include some kind of motors in that. Okay, that is basically called a robot. Okay. See, civil, not completely civil. Like basically from the civil, I want like whenever you have to make a robot, first of all you make a design of that robot, right? You make a carbon like blueprint of that robot. So that blueprint making, like how you will be designing that, what will be the angle, and what will be the different features of that can be the part of civil. Not completely, but in some way you design in some different softwares, and that software comes under civil engineering. Okay, so that is why I am saying somewhat civil, not completely. Okay. Yeah. Now next one, coming to the some little bit of history about this robotics. The robot word is first used to denote fictional humanoid character in a play RUR, that stands for Rossum Universal Robot, by a Czech writer Karel Čapek. So Karel Čapek was a writer who was basically who was there was a play. Basically the play name was Rossum Universal Robot, that was organized by the Karel Čapek, and in that play there was a humanoid robot, and that humanoid character was named as a robot. So from there this robot word has been derived. Basically they have taken the word from that play. So basically this word is derived from the word robota, which means a forced labor. Like what is a forced labor? Labor means who does our work, and forced labor means who is forcefully doing our work. If I'm giving an instruction, he has to do the work. So robotics is a robot word is derived from a word robota, which means forced labor. That means if I'll give an instruction, he has to do that work. But if I talk about human can deny to do that work, right? He can deny, but robot will never deny. He has to do that work if you are giving an instruction. If he is denying that, that means he is, you can say, failing the law. He is breaking the law of robotics. Okay. So this is about robotics, a history basically. Then coming to the laws of robotics. Now, this law is given by the science fiction author, which is Asimov, as Isaac Asimov, and he has given 3 laws of robotics. He told that in some future there will be some machine which will follow these 3 laws, and if it is follow these 3 laws, then we can say that robot is a good robot. But if he fails in any of the 3 laws, then it means that it is breaking the law of robotics. So the first law is robot must never harm human being. Whatever the condition is, he should never harm the human being. That is the first law. You must have seen the robot movie, that Rajnikant robot movie. In that movie, when he has taken that robot for the inspection, for the approval, that robot was not approved just due to this only, that he was harming a human being. When he was instructed to harm, he has harmed that, right? So basically, he must not harm the human being, whatever the condition is. Second one, he must follow the instruction from human without violating rule 1. So he has to follow the human instruction, but if the human will say that go and harm that person, he should not do that also. Okay. So basically, he should not harm the human. He should follow the instruction without violating the rule 1. And the third one, he should protect themselves without violating the other 2 rules. So he has to protect himself also. And it's not like that for protecting himself, he is harming others. No. If he is harming others for protecting himself, it means that he is breaking the first law. Because the third law is saying he should protect themselves, but the first 2 laws should also be followed. Okay, so this is about the laws of robotics. If any robot follow these laws, then that is a good robot. Okay. Now coming to the features or characteristics of robot which a robot should have. Okay, the first one is mobility. So it should possess some form of movement. It should have a mobility, which is a very important part of robot. So it should have some kind of mobility. Second one, programmability. It can be programmed to accomplish a large variety of tasks. After being programmed, it operates automatically. The reason why a robot is a multitasking unit. So if you want to make a robot as a multitasking, then you have to make it programmable. It should be programmed. You have to write some programs. Okay, Bharat, just wait. I'll explain that. Third one is sensors. On around the device, they are able to sense the environment and give some useful feedback to the device. So there should be some kind of sensors attached to the robot to sense the changes in the environment. To sense the changes in the environment, right? So it can be your IR sensor, it can be your ultrasonic sensor, it can be your sound sensor. There are so many sensors that we have in the robotics. Okay. Next one, it should have the mechanical capability. Mechanical capability means enabling it to act on its environment rather than merely function as a data processing or computational device. Now, what is the meaning of this? As this is a machine, so the main task of the machine is to, if I talk about computer, it makes some kind of data processing or computational, do some kind of operation. So robot should not do only this thing. It should be capable of doing something according to the environment. Let's say if there is some object coming in front of the robot, he should take a turn from there, or he should make a move from there, that he should not strike that object. So he should act accordingly according to the environment. That is what a mechanical capability is. And the last one is flexibility. It can operate using a range of programs and manipulate in variety of ways. So it should be a multitasking robot. We can upload multiple programs, like a range of programs in a robot, but only one program should be run at a time. Because in embedded system, you can only run a single program at a time. You cannot run all the programs at the same time. For that, you have to use a computer kind of thing, where should be a processor also, where should have some memory also. There's so many things should be there. So flexibility means you can change, you have the option to change the program so that it can manipulate in variety of ways. So these are some features which a robot should have, a machine should have. And if the machine is having these all features, then we can call it as a robot. Okay, I hope this is clear. And now see, one of you are asking about the third one. Robot must protect themselves. Like the meaning of this one is that robot must protect himself. Let's say if I am a robot, if any person is harming me, then I should protect myself with that person. But for protecting myself, I should not harm that person. I should simply protect myself, but I should not harm. That's the meaning of this third law. Okay. What kind of programming language? There are so many programming language which you can use for robotics, like C programming, embedded C programming. Then you can use Python programming. But according to the different hardware, you have to choose the programming. Okay. So basically, two programming language we use: Python and embedded C language. Okay. And C++ is also there, but embedded C is far better than C++. So basically, embedded C is based on C++ language only. Okay. Now the last one is mechanism. How a robot work? Like if I ask you about our mechanism, how a human work. Like if I take an example of if I touch a hot body. So if I touch a hot body, my skin, if I'm touching with my hand, my skin is touching that hot body. So skin will sense that hot body. And after sensing that hot body, it will send a signal to the brain that I have touched a hot body. So what the brain will do? Brain will send that signal to the hand that remove your hand. Right? This is how the human work. Same thing we have in the robotics also. In robotics, we have some sensors that senses the change in environment, and after sensing that value, it is sent to a controller, a microcontroller or microprocessor. That controller process that input, whatever input is received by the sensor, and according to that input, it is sent to the actuator. So actuators are basically the devices which makes movement, like motors. Motors are the example of actuators. Okay, so this is how a robot work. There is a sensor which senses some value. That sensor, that input value taken by the sensor is sent to the controller. According to that input value, controller gives an output to the actuator. Actuator can be the motor. Yes, right. So this is this is a mechanism of a robot. So basically, can you tell me, if I consider an example of a human, what is a controller in human? Sensor, I told you we have 5 sense organs: eye, nose, tongue, ear, and skin. But what is a controller in a human? If I consider this as a human, if I compare this as a human, yes, correct. Brain. Our brain is a human. Okay, so brain is a human. Our brain is the controller in a human being, right? So brain is the controller, and in our case, what are the actuators? What are the actuators in our case? What are the actuators in our case? Yes, you can say limbs, your legs, your hands, These are the actuators, right? Correct. So this is a mechanism how a robot works. So I hope you got some basic idea about a embedded system and a robotics. Okay. Now I'm going to give you some practical thing about this embedded system. So for this, as we are doing it session live online, so I will be telling you about one simulator on which you can do the practical related to the embedded system. So I'll give you some basic projects, some small projects related to a embedded system on the simulator. That simulator name is Tinkercad. So you can go to Google, can go to Google and you can search for Tinkercad. It's a free of cost platform and it is developed by the same company which developed the AutoCAD software. You must have heard about AutoCAD software, no? So the same company has made that, and company name is Autodesk. Okay, the same company has made this. You can make a 3D design also here, and you can make some circuit related to the Tinker embedded system here. And the board that we have here, that board is Arduino. I hope you must have heard about Arduino board. It's a very famous board in the case of embedded system. So this Arduino company has developed this board for basically for the non-technical persons, because the programming is very much simple to understand. Even a non-technical person can also program this board. So this is free of cost. This Arduino software and a programming completely, it is free of cost. Just you have to purchase a board and you can write the program in this. So basically that Tinkercad supports this Arduino board. We have a Arduino board in that simulator, and there you can connect different components and write the program and see the output there itself. You don't need a hardware for getting the output. Without the hardware, you can do so many practicals. There are numerous number of components that you can use there. I'll just show you right now. Okay, so basically you have to go to this Tinkercad. I'll provide the link on the chat if you want, but you can simply search on Google Tinkercad. When you search on Google, you will get the first link and you have to simply go to this link. And now see, let me log out. Okay, see, when you open this link, you will be getting this page, basically this website of this Tinkercad. Okay, so on this one you have to simply join now. It's free of cost. So you can simply click on join now button on the top right, and here you can click on create a personal account, and here you can simply sign in with your Google account. So you must have the Google account, so simply you can sign in with your Google account. Okay, so after signing in, you will be getting this page. Yes, I am sending the link if you want. Wait. Take the link. I've given in the chat. Okay. Okay, fine. Now, here if you see, we have 3D design, we have circuits, we have code blocks, we have lessons. So there are so many options. So basically for our purpose, we have to use circuits option. So these are the circuits which I have previously made in this website. So you have to go to this circuits and you have to click on create new circuit. Create new circuit. Yes. So this is the page that you will be getting after creating the new circuit. Now on the top left here, this is the project name, you can say, the file name. So you can give the file name to anything. Let's say I'll give the file name as lab1. You can give it anything, that whatever you want to give here in the top left corner. Okay. Then on the right hand side, if you see, these are the components. So by default, it will display only the basic components. So if you click on this, there are some options here. So if you click on all components, then you will get the list of all the components which is available here. If you see here, there are so many components which are available here, which you can use for different projects. See, so many projects are so many components are there. Even everything, almost everything is there. See, okay, see, there are a long list here. Some chips is also there. If you see, some chips is also there. Okay, so basically for this one we have to go for Arduino. I'm going to tell you the basic thing to turn on the LED using a program. Using a program, we are going to turn on the LED. So in the search bar, you can search for Arduino and see this Arduino Uno board we have here. So this is the single board that we have here. This is an online simulator. You don't have to download anything. It's an online. So this is the Arduino board. You have to click on this Arduino board and take it here. Simply click and you can take it here like this. So we have taken here one Arduino board. To zoom this, you can press Control and you can scroll your mouse. It will zoom in and zoom out like this. Okay. So this is the Arduino board which we have taken. Now, if you want to glow a LED, now tell me, I hope everyone know about LED. You know what is an LED? Must have used in your junior classes or in your college right now, anywhere. Basically, it stands for a light emitting diode, where you can, it is basically used for a light, it emits the light, and it has two terminals. One is a longer terminal and another one is a short terminal. So the longer terminal is a positive terminal and the smaller terminal is a negative terminal, right? So it is like here you don't have to connect, here you have to connect the positive terminal to the positive and negative terminal to the negative. So you have to check the polarity because it is a polarized component. There is a polarity for this. Okay, so basically if I ask you about the basic connection of LED, what do we require to turn on the LED other than battery, other than power supply? What do we require? Can we connect the battery directly to the LED? Can we connect? See, I'll show you. Basically, if I say, see, this is the symbol of LED. This is your positive terminal. This is your negative terminal. So if I have to connect LED, I cannot directly connect to a battery. If I am having a 9-volt battery, let's suppose, I cannot connect because it will make that LED fuse. So we have to connect a resistor in that LED. So let us say that we'll connect 1 kilo ohm of resistance here. Okay. And then a positive terminal, negative terminal. So this is my battery here. And this is 1 kilo ohm of resistance, right? So if you connect like this, your LED will start glowing. Okay. It will start glowing. But in case of this Arduino, we will not connect this one. This part will not be connected. In place of this, we will be connecting the Arduino Uno. And through Arduino Uno, I will be making this LED turn on or turn off. So basically, if you see the Arduino board, let me show you. You can see there are so many pins here. See zero. See, I cannot tell you more details. Like I cannot go in more deep about this because we have a limited time. But I'll give you a short overview. And if you see here, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are called the GPIO pin, which stands for General Purpose Input Output. So these are the pins where you can connect a hardware as an input hardware also, as output hardware also. So you can make these pins behave like an input or like an output. Okay. So basically, these are the GPIO pins. These are the analog pins where you can connect your analog input sensor. And these are the power supply pins like 3.3 volt pin, 5 volt pin, ground pin. So in this case, these are the pins which we can use it as the output or input. So let us suppose that I will be using pin number 3 for the as a positive pin of the LED. That means if this is an LED and this is a positive pin, this is a negative pin. So this part of pin will be connecting first of all to a resistor, and then through a resistor will connect to pin number 3. Let's say pin number 3. Okay. And here, this negative pin we will be connecting to the ground of the Arduino. So through the program, now what we have to do through the program? Through the program, we have to give this pin number 3 some kind of output, and the output that we use in embedded system, you must be knowing that electronics works on 0 and 1. Where 0 is equivalent to 0 volt and 1 is equivalent to plus 5 volt. Okay, so basically, if I will provide 1 to this pin number 3, this pin number 3 will behave like a plus 5 volt pin. So that means it will simply turn on the LED. And if I'll connect the pin number 3, if I'll provide pin number 3 as a 0, so it will provide 0 volt. So the LED will be turned off. So simply you have to give the output to pin number 3 either as 0 or as 1. So if you are giving the output as 0 and 1, it will be called as the digital output. Digital output, because you are giving the value as 0 and 1. Okay, but if you are giving the value between 0 to 1023, this will be called as an analog output. Now, why 0 to 1023? Because in this Arduino, we have a 10-bit ADC. ADC stands for analog to digital converter. So if you calculate 2 to the power 10, it will be 1024. And that is why when you give the analog voltage, it divides that 0 to 1 into 0 to 1023, where 1023 is equivalent to 1 and 0 will be equivalent to 0. So that means if I am providing 1023, it means that I am providing a complete 5 volt. But if I am providing, let's say 512, that means I am providing a voltage 2.5 volt approximately. So in the analog output, you can divide the voltage. You can give a voltage, you can change the brightness of the LED by differentiating the voltage. So I hope this thing is clear. Okay. So basically, I'm giving you example right now for the digital output, how you can give a digital output to the Arduino. So for doing that, I'll come back to the circuit. Now, first of all, we have to take an LED. So I'll search for the LED here. LED. And see here we are getting this so many types of LED. So the first one, I'll take the basic one. This is the LED. So I'll click on this and I'll take it here somewhere. Let's say I'll keep it here. Okay. Now if you hover the mouse here, you can see it is cathode and this one is anode. So anode means positive and cathode means negative. Okay. And if you click on the LED, you can change the color of the LED from here. Green, yellow, orange, blue, red, white, whatever color you want to take, you can take the color from here. Okay, so let's say I'll take it as green, or you can take it as orange, whatever you want to take, you can take it here. Okay, then now this cathode, the negative terminal, will directly connect to the ground. So I'll just take the wire like this. Let's say I have to turn, so I'll click here, I'll click here, I'll click here, and I'll click here. See, so we have connected the negative terminal of the LED to the ground. Now for the positive terminal, we need a resistance. So I will search for resistor here. So you can see this is the resistor. So let us connect the resistor to the positive terminal. If you click on the resistor, you'll see that this is the value of resistor 1 kilo ohm. So by default, it is 1 kilo ohm, 1000 ohm. If you want to change, you can change it from here. But right now, I'll keep it as 1 kilo ohm, or you can change it to 500 ohm. That will also be enough. So I'm giving here 0.5 kilo ohm. That is equivalent to 500 ohms. Okay. Now this resistance will be connected to any of the GPIO pin. So let's say I'll connect to pin number 3. See, that is a simple connection I have made. So like this, you can simply connect your Arduino with the LED. See, so this is the complete connection. Now we have to write the code to make this LED glow. So here you can see there is a coding option, code. So if you click on this code, now see, here we are getting some blocks. This is called block-based programming. So this is basically for those person who are completely non-technicals. Because here we don't have to write anything, any program, any kind of program. This is simply drag and drop kind of program. Okay, so basically we don't have to use this one because we are going to learn about simple program. So we will select here, and I'll change this to text. I'll change this to text. Okay, so I'll click on this text. It will ask you one confirmation. So click on continue. And this is the program, the default program written here. And this program is known as embedded C programming, which is based on C++. Okay. So now let us look at this program. So here we can see there are two things, setup and loop. In the setup, we basically define on which pin you are connecting your LED. As I told you that these all GPIO pins 0, 1, 2, 3, all these pins can be used as an input, can be used as an output. But Arduino don't know anything. He don't know which pin you are using as an input, which pin you are using as an output. He is completely dumb. He don't know anything. You have to tell him everything, that this is input, this is output. You have to tell him. Okay, so basically, how to do this? Here, this pin mode function is used to define. So here I will write the pin number which I want to define. So let's say I'll write here pin number 3. And what I want to define it as output because LED is an output device. LED gives the output, LED gives the light. So here we will define the pin number 3 as an output pin, and output should be in capital, and here M should also be in capital. So the meaning of this line means that we have defined pin number 3 as an output pin, and why 3 only? Because we have connected this to 3. I hope this is clear. And everyone present here, if you like this session, please like this session and share with your friends and subscribe to our channel also. There are more than 400 participants watching this session. Click on the like button, everyone, and make it 400. Please support us by liking this video. Okay. Yeah. Okay, so here we have basically defined the pin. Now coming to the loop part. Whatever code you will be writing in this loop, it will be executing for infinite number of times. So I'll just remove this code right now. Now see, right now we just have to turn on the LED. We have to glow the LED. So basically to glow the LED, is it required to write the code in loop? Tell me. If we have to simply turn on. For certificate, I'll tell you later on. Just focus on the session right now. No need, right? You can write in the loop, but actually this is not mandatory to write in the loop. It doesn't make sense to execute the same code again and again because it is not changing. So I will write in the setup only. I'll write here digital write. Here W is capital. Digital write means that we are writing this, we are giving a digital output to my Arduino. How infinite loop can be controlled, I will tell you. Wait. Then here in the digital write, you will write on which pin you want to give the output. So I'll write here that I want to give the output on pin number 3. And I will write here 1. That means I want to make it on. Or if you write high, this is also okay. So high is equivalent to 1. High is equivalent to 1. Okay. So now if I close the bracket and give a semicolon, so now through this line, we are making the pin number 3 high. Am I clear? Okay. So this is a simple program to turn on the LED. And if you don't do this thing, this line will not work. So for making this line active, for making this line work, you have to execute this line. This line should be there. Okay. So now to run this code, you have to click on start simulation. Start simulation. And you can see the LED is glowing. I hope you can see that. Let me zoom this. See. Okay. If I stop, it's closed. Yes, you can use any pin, 0, 1, 2, 3, 4, 5, 6, 7, any pin you can use, but you have to define that pin wherever you are connecting. Let's say if I delete from here, oh, sorry. If I delete this wire and connect this to, let's say, pin number 5. Pin number 5. So in the code, I have to define that pin number 5. See, if I run this code now, the LED will not turn on. See. So you have to give your pin number 5. See, it's on. No, you don't have to give the input supply because this simulator is by default giving that. If you see on the left hand side, it is connecting to that USB cable. See, okay. So you don't have to give the input supply. And see, if I write here low, the LED will not turn on. It will be low. It will be off only. Okay. So I hope this thing is clear, everyone. Yeah. Okay. That is the internal one, huh? If you don't have the external LED, then you can use that internal LED. Okay. Like here, if you see, just beside the Arduino logo, here we have the L written here, L. So this is the internal LED. In the hardware kind of thing, you have to give the power supply using this cable only you can give. When you upload the program using this cable, there will be a power supply with your laptop, or you can connect a 9-volt adapter in this black part here, this one. Okay, so that is how you can give a digital output to an Arduino. Okay, now coming to the, let's say if I want to take two LED, yes, I'm coming to that only. I want to take two LED and I want to make it on and off alternately. So how can we do that? So for this, we will take one more LED. So let's say I'll take here LED and I will connect here. Let's say, okay, let's take here itself. I'll take one more resistor. Okay, now this one should be connected to ground. So I'll again connect this to ground. See, for multiple LED, it will be better that if we use breadboard. Do you know about breadboard? Let me delete everything. Yes, this video will be available every time. See, we have different options of breadboard. This is a bigger one, this is a smaller one, and this is a mini one. So let's take the smaller one. Yeah. In this breadboard, if you go for this line, this line is internally connected, internally connected to each other, horizontally. If you go for second line, same, they are horizontally connected internally. For this one, they are vertically connected. That means if I connect a pin terminal to this pin, and if I connect a terminal to any of these pins, then they will be internally connected to each other. Okay, same thing is here, and at the bottom they are horizontal. So it means if I connect this ground pin, if I connect this ground pin to this pin, then what does it mean? It means that all these holes you see here, all these holes will be acting as a ground now. Now these all holes are ground now. Everything. The first line is a ground. They all will act as a ground. Okay. So now I'll take two LED. So I'll take here LED. Now just tell me, can I connect LED like this? And I connect LED like this. Out of these two LED, which one is the correct one? The first one or second one? LED stands for light emitting diode, which is used as an output device. Second one, yes. The first one means that we are making these two terminals short. Okay, so you have to connect LED like this. This is the correct connection because these two pins are not connected. Okay, now this is cathode, this is anode, cathode, anode. So for this one, I'll just connect this here. Okay, for this one also, I'll connect this to here. That means I've connected the both terminal to the ground. Fine. Then coming to this pin is anode pin. So we'll connect to any of the two data pins. So I'll connect like this. Let's say I'll turn from here. I'll go to pin number, let's say pin number 2. And this pin I'll connect to, let's say, pin number 4. So I've connected to pin number 2 and pin number 4. So this is the connection that I have done. Now let me change the color of one LED. So this LED, I'll take it as, let's say, blue, and this one as a red only. Okay. Now I want to, sorry, I missed the register. Okay, yes. But here I can ignore this because this is a software, but in the actual hardware you have to connect the register. So here I am ignoring this, but in the actual hardware you should go with the register. Okay. But if you want to connect, I'll connect. Wait, let me connect the register now. So wait, I'll do that. What I'll do, I'll take a register here. I'll connect like this. I'll connect like this. Now see, I've connected this one to this one. It means that this one is now connected to this LED. This one is also now connected to this LED. Now these holes are now empty. This is empty now. So here I'll connect this terminal to pin number 2, let's say. And this pin I'll connect to pin number 3. Yes, you can use RGB LED. I'll give you the example of that also. Wait for some time. Yeah. So on pin number 2 and pin number 4, I have connected my LED. Okay. I'll make the LED to 500 ohms. So 0.5 kilo ohm. Okay, so I hope this connection is clear, everyone. Okay. Now coming to the programming part. We have used pin number 2 and pin number 4, right? So I'll define the pin mode. Pin number 2 as output, pin number 4 as an output. Okay. Now I'll remove this line from here. Now, as I told you, I will be alternately making it on both LED. Both LEDs should be alternately on. So see, if I write here in the loop, digital write 2, high. Okay. Digital write 4, low. Now see, in this case, the pin number 2 will be high and pin number 4 will be low. Okay, pin number 2 will be high, pin number 4 will be low. That means whatever we have connected on pin number 2, that LED will be on. Whatever we have connected on pin number 4, that LED will be on, off. Now this will be executed for infinite times. But as I told you, we have to alternately make it on. So that means we have to make this also on. So what I'll do, I'll just write below this line. Here I will make it low and here I will make it high. Now see, as this is a part of loop, so this will be done first, this will be done first. But the speed of this one will be very high. The speed of this one will be very high that you cannot see this thing, this blinking. You cannot see that. See, if I run this code, see, can you see? If you see here, both the LEDs are glowing at the same time. Can you see, everyone? They are glowing at the same time. We cannot see on and off because these all codes are executing very fast. It's executing very fast. The throughput of this Arduino is 16 MIPS. It means that it is executing 16 million instructions in 1 second. But here we have only 4 instructions. Okay, so we have to give a delay so that we can see this blinking. So I'll give a delay here, delay of 1000. 1000 means 1 second, 1000 millisecond here, 1000 millisecond is equivalent to 1 second. That means it will stop the code, it will hold on this code for 1 second. Then we have to hold on this code also. Then we have to give a delay here also. So it will be holding on these two codes for 1 second and these two codes for 1 second again, and it will be repeated. Now if I click on start simulation, now you can see red, then blue, red, and blue. See, now they are glowing alternately. Okay, I hope you understood this. Delay is like a pause. It's like a pause. It's like a pause that you are giving. It is holding these two commands for this particular time. It's like a hold, or you can say pause. Okay, so like this, we are making this LED glow. Okay, I hope that is clear. Now I'll give you one more short example, last example, and that will be example of analog output. So for the analog output, let me stop this code, and let me remove these connections now. You can increase the speed now, like you can give a short delay, let's say 100. If I give it 100 here, the speed will be higher. See, now it's higher. According to the delay, the speed will be changing. Okay, now let me remove all these things. I'll provide this code on the chat if you want. Wait, take it. Maybe it is not coming. Okay, it is going. Okay, I'll provide the code. Wait. Yes, you can say it as it is an example of traffic light. Yes, correct. You can go to this link and you will get the code. Okay. How much programming language do we need to master? Basic, like basic programming. If you know a basic C language, then you can learn about this. Basic knowledge of C programming. Okay, now coming to the next part, analog example. I'll just delete everything. Okay. Now see, for this analog one, I will take an example of RGB LED. RGB LED. Now, do you know what is RGB LED? Yes, you can do using Python, but you have to use Raspberry Pi board for that, not Arduino. In Arduino you cannot use Python programming. Yes, this stands for red, green, and blue, not black. Red, green, and blue. And through this RGB LED, you can glow the LED to any color. To any color that you want. By mixing these three colors, you can make any color. So for that, we have to take register also. So I'll connect. Now see, there are 4 terminals here. Red, cathode, blue, green. Red, cathode, blue, green. So cathode is a negative terminal, and we have 3 positive terminal and 1 negative terminal. So cathode will simply connect to the ground. That is simple. But for the other 3, you have to connect the resistance first. This is mandatory in this. And let's take a 500 ohm resistance, 0.5 ohm. Now see, if you are taking an analog output, you have to take an analog output pin, which is also known as PWM pin. pulse width modulation. So these are the pins related to pulse width modulation, where you can see this analog sign. Can you see the analog sign here? 3, 5, 6, 9, 10, 11. These are the PWM pins. So you can get the analog output on these pins only. If I connect to 2, you will not get. Connect to 4, you will not get. So you have to use these 3, 5, 6, 9, 10, 11. These 6 pins only. Okay. So basically, let us say that I'll connect this red pin, this red one, to pin number 11, blue one to pin number 10, and green one to pin number 9. Yes, you have to connect 3 resistors. Yes. So red pin I have connected to pin number 11, blue I have connected to pin number 10, and green I have connected to pin number 9. Now, coming back here. So first of all, we have to define all the 3 pins. So what I'll do is I'll define a variable here to make it simple. Int red equal to, so we have connected the red pin on pin number 11. Int blue equal to 10 and int green equal to 9. I define the pin inside a variable. Okay. Then here I will define pin red, green, and blue as an output. Fine. Now see, let's say I want only red color, or you can say first red, then green, then blue. Now let me show you one thing first. If you see the HTML color codes, like we have a hexadecimal color code. If you see here, for every code we have a RGB value. If I show you for the red one, see, if I go for the black color, the value of RGB is 000. If I go something for red one, see, 98, 89, 18, and 44. Okay. So you have to give these values only. The maximum value is 255. If you go for the white, see, if you make all the 3 as 255, it will become a white color. If I go for the red color, see, wait, let me take a red color. See, for the red color, we have 255 for red, and for blue and green, it is 0. If you go for the blue color, similarly, blue will be 255 and other will be 0. Okay. So basically, here, so I'll write here analog, right. Let's say I want to give the red color as 255. Other one I will give it as 0. So blue one as 0 and green one as also 0. So this will be red color now. Then let's say I'll give 3 times. So I'll make this 0 and this 255, this 0 and this 255. So first of all, I'm glowing red, then blue, then green. And here we have to provide a delay also. Let's give a delay of 500. Now let's see the output. Let me zoom this. You can see it properly. See, red, blue, green. See. Okay. Okay. Now see, if you want any particular color, let's say you want any particular color. First of all, let me share this code with you. It will be with you. Okay, you can take from the chat. I've given the current code. Yeah, for any particular color, we'll not provide this number of lines. We can directly write these lines here because we want a single color. Okay, so no need to write in the loop. Now see, let's say I want something color like this. So if you see, for this color, the value of R is 191, green is 47, and blue is 229. So I'll write here R as 191. So R value will be 191. Green will be 47 and 229. Now see, if I run this, now can you see we got a color like this color. So whatever value you will be giving here, it will be giving the color according to that value. Let me make one interesting thing here. Let us randomly give the color, random colors. So for random color, what I will do is, instead of doing this, I will write here random 1 to 255. So it will be generating the value between 0 to 255. Any value between 0 to 255. So let's try this one and let's see how different color we get here. Yeah, so I've given for all the three. So now let me give a delay, because if you don't provide delay, you cannot see. So I'll provide a delay of, let's say 700. Now let's see. See, yellow, then something green, then you can see you will get now different colors every time. Okay. So like this, we can make some projects on embedded system in this Tinkercad, and I hope you can see how simple it is. And we don't need any kind of hardware. We can do everything here. Most of the things we can do here. And if you can do here, same thing if you apply to the hardware, it will definitely work. Okay. Now, so this is all basically for this. Now, basically, if you want to learn about this Tinkercad in more detail, about some many big projects, then we have one training. And before going to that part, all of you please like this video and share with your friends also, and subscribe to our channel. Please make this live like as 500. All of you are watching this, all of you click on the like button. I hope you are liking this session. So why you are not clicking on like button? Click on the like button. If I'll provide this code. See, if you want to learn about this Tinkercad in more details, we have one training. It is 2 weeks training, 3 hours per day will be the session, and it is going to start from the coming Monday. On coming Monday, it is going to start. So I'll also give you the details about this, and if you are interested, you can participate in that. And we have a limited seats in that. We have only 40 seats, and the registration is going on now. So if you're interested, you can participate in that training. I'll give you the details. You can go to our website, finlandlabs.com. I'm providing this link on the chat. See our website. If you go on our website, in this online course, you will get that these are the different courses which we are giving right now online. So if you're interested for this one, you can go to this embedded system with robotics, this one. And this is the link where you can get each and every details. Okay, so just a minute. I'll give this on the chat also. So here you will get the details about this training. And if you scroll down, click on read more, and here this is the course content of this complete training. So these are the topics which we will be discussing in that training: concept of electronics devices, electronics component, then introduction to Arduino, hands-on with Arduino, sensor interfacing. You will be learning about different sensors, interface different sensors. Okay, embedded system concept. What is embedded system? What is microcontroller? What is microprocessor? What is RISC versus CISC? These all things we'll be discussing. Then introduction to Atmega 328 microcontroller. This is a controller which we are using in the Arduino board. So we'll learn about this one. Then introduction to pulse width modulation. These are the different types of sensor and components which we will be using to interface in this training: temperature sensor, ultrasonic sensor, IR sensor. Okay, by mistake they have given 2 times. Okay, LDR, which stands for light dependent register, gas sensor, IR remote, keypad for 4x4, like this can be used for a password. Okay, potentiometer, then RGB LED, PIR sensor, push button. And these are the motors, how to interface motor, how to operate motors using Arduino board. This thing we'll be learning in this. Then serial communication, then LCD, and these are the projects that we will be doing. And all these projects will be done on the Tinkercad. You don't need any hardware. Traffic light controller, creating a dimmer circuit, distance calculator or object detection using ultrasonic sensor, fire alarm system using temperature and gas sensor, light intensity measurement using LDR, password protected security system, controlling LED with using IR remote, printing text on LED. So these are the different projects that we'll be doing in this complete 2 weeks. And you don't need any kind of hardware. Everything will be done on Tinkercad. No, it's not free. The fee is 2,500 per participant, and if you are joining in a group, you will get some discount also. Okay, so you can go to this link. I'm providing this again on the chat. Explore this, and if you are interested, you can participate. The registration is going on, and we have a limited seats. So I'll recommend you can participate in this, and I will be taking this session. Okay, so you can learn about this in more details. Fine. You will get the complete recording of this complete session also. Day by day recording will be provided. Certificates will be provided with the Finland labs. So half an hour session every day will be the doubt session. So separate doubt session we have in this session also. So you can participate if you want in this. Okay. No, we don't have the simulator as of now for the Python because we have to use Raspberry Pi. Okay. Yeah, so the timing will be 2 to 5, I think. Yes, 2 to 5 p.m. and starting from 20th of September. Okay. Yes, I'll provide the link right now. And I'm right now going to provide the attendance link to all. Please fill the attendance form carefully. Don't fill your names wrong. Whatever you will be filling, the same name will be printed on your certificate. And please check the description. There is a Telegram group. Please join the Telegram group. We'll provide the details about the certificate in the Telegram group, and you will get your certificate in that Telegram group within 72 hours. Within 2 to 3 days, you will get your certificate. So we'll inform in that Telegram group about the certificate. So please join the Telegram group as soon as possible. Okay. It's a 2 weeks training. Monday to Friday will be the classes. Saturday and Sunday will be holiday. So total 10 days training will be there. 30 hours course is there. If the Telegram link is not working, please download the Telegram first. Then click on the link. Maybe the Telegram is not there. Maybe that's why it is not working. Or maybe you are clicking the Telegram link in your system. You have to click in your mobile. Then it will work. You have to click the Telegram link in your mobile with the Telegram installed. If you install that, then it will work. Fine. So those who are not in the Telegram group, please join the Telegram group. Wait. This is the Telegram group I am giving on the chat. Take it. Okay. Now I am providing the attendance link. Take it. Okay. Telegram link is in the description. So please do try to join that session, 2 weeks training. It will be very interesting. You will definitely enjoy this. So register fast. The seats are limited. It is going to start on Monday. Okay. Yes. So I hope you all enjoyed this session, everyone. So please click on the like button, everyone, those who are present here, and make it 500 at least. So click on the like button and share this video with your friends. And this video will be available on YouTube on our channel. Every time you can come back here every time and you can check this video. Okay. And you can explore some other trainings also. These all are the training that is going to start in this coming days. So these all trainings is going on right now. So you can go here and you can explore about different trainings. Like we have image processing with Python, AI and machine learning, embedded system, deep learning using medical data, cloud computing, IoT using AWS, blockchain, data visualization using Tableau. This is a very demanding training right now. Android app development, web development. These are the training which is going on right now. You can go and participate there. Okay. See, Niladri, in 1.5 hours, we cannot cover much. We can just give you an overview. Okay. Yeah, thank you so much. Attendance link, please try again. Maybe all of you are opening at the same time. Maybe it gets a problem. You can try after some time. It will be active for at least 1 hour. So don't worry. Okay. Yes. Anyone, any doubts, any queries related to the training? I'm providing this link again on the chat. If you're interested, you can participate. Okay. Attendance field. Okay, great. Website link. Okay. This is our website. Simply you can search on Google also Finland Labs. You'll get our website. Certificate, I told you we'll be providing the certificate details in the Telegram group. Please join the Telegram group as soon as possible. Okay. So everyone, please click on the like button, those who are present here. And please subscribe to our channel if you are not subscribed. And those who will only fill the attendance form, they will only get the certificate. Remember that attendance form is mandatory. If you don't fill that attendance form, please don't tell us later on that you don't get the certificate or not. We'll provide certificate to only those participants who will be filling the attendance form. No, right now, basically, these are the two programming languages that we can use. There is no other programming languages that we can use for this. Okay, like we have a Node MCU hardware which is basically a Lua based programming, LUA. That is also another programming language that you can use, Lua programming. Okay. Telegram group, please check the description of the video. You will get the Telegram group link. I'll provide a Telegram group content. Data science with Python. Right now, it is not active. Bharat, be active on the website. We will update on the website as soon as the training will be available. Okay. Right now, it is not active. You can join the AIML training. That is similar to data science. Okay. AIML training you can join. That is also going to start from the next week. From coming Monday, it is going to start. This one. Thank you so much, Niladri. Thank you so much. This one you can join. They are the contents. Okay, you can join this one, this training. I'm providing this link also on the chat. Okay. Yes. Now, any other queries? And please don't call or message for the certificate. If you are filling the attendance form, you will definitely get the certificate. So please don't personally call or message. Please click the link of the Telegram in the phone after installing the Telegram app in your phone. Then this link will work. Okay. Attendance link, maybe it will not work. Can try after some time, because lots of person are using this right now. So you can try after some time, it will work. I'll provide the attendance link again. Take it. Certificate you will be getting within 72 hours. Yes, we will be giving more free classes in coming days. Subscribe to this channel. Whenever there will be some free classes, you will get the notification of that. Okay. Okay then. So thank you so much everyone for joining this session today. I hope you all have registered for that training. So if you have registered, I will meet you in that training in the next week, Monday. Telegram group name is Finland Labs. Okay. So bye everyone. Take care and have a nice day. Thank you so much for joining today. Bye. And please do subscribe this channel and like this video. Okay. Bye.